My name is Bashar. I am here to present Al Ghurair Construction Aluminium. It's a Dubai-based company established in United Arab Emirates in 1967. We are completed 46 years of doing curtain wall, windows, doors, cladding in that region. And this company, when was established 46 back, the people used to use in our area wood, used to use different elements to build their windows and doors. So we were the first company to introduce the aluminium to the construction industry. This is some photos being taken from various projects we executed in that region. And as we mentioned, we do different solutions for the envelope. We do steel structure, and in addition to the curtain wall and the windows, doors. Today, I'm going to share with you the influence of the Arabic culture in the GCC area on the construction which been built as an envelope the last few years. The culture which was reflected in certain building. This photo being taken from our area, from desert, from old building, showing mashrabiyya, showing the decking machine for oil. On the corner, that's flower which used to grow in the desert. We need to show you how this element, it come as a part of the new envelope which being executed in our regions. Now, in our region, you know, the culture, the historical background, the religions, the climate, it has a big impact on all the architects, and it makes them really take that consideration when they design the envelope of certain project in our area. For example, we will take one element which is mashrabiyya. This element used to be used long back. The people used to use it to provide privacy, to provide shadow, and in addition that, it also the beautiful appearance of this mashrabiyya, which used to be done by handmade. Now, this mashrabiyya, it's being used in so many projects now, in, for example, in UAE and Dubai, in the Old Town, if you know this project. It's being done as aluminium from a different product. Recently, we just executed one big job in Riyadh, where the architect with us, we developed this mashrabiyya to make it look more fashion. We use aluminium metal with powder coating, and we make it in a diamond shape, perforated with, again, diamond shape and a different dimensions. And we cover complete 4 towers with a total area of 80,000 square meters. Now, this is how the building looked after we cover it with this mashrabiyya. And the gold color was chosen to be close to the desert color to reflect, again, the surrounding area of the towers. It's this project called ITCC, located in Riyadh. We also did one more, we add a facade lighting system on the mashrabiyya, which I'll show you now here. No, here we're talking about, sorry, the suspension system. This mashrabiyya, if you look to the weight, it's heavy. So when we design it from aluminium, 6mm sheet. We hang the system completely from the roof, so there was no load transfer to the slab of the building. All the dead load being hung from the top. We just transferred the wind load back to the building, and we avoid penetrating the system to keep the envelope sealed 100%. Also, to reduce the weight, we use carbon material, the connecting plate. There was a a different idea to use steel, to use a solid aluminum, and that will end having a lot of weight on the building. So we come with a use carbon composite, which is 3 times less weight. Then we again came with another idea to the client to put facade lighting, media lighting, on the connecting plate, which will make the building look more beautiful in the night. And you can also present some photos, but not that much high resolutions. This is some photos being taken from inside the building, where you can see that it's improved a lot, the shadow, the cooling system of the building, especially in a city like Riyadh, where the sun in the summertime, it shines for almost 16, 17 hours. And you can see here the Mashrabiyya hang in a rod of 18 millimeter from top of the building. And we provide catwalk all around to be able to clean the facade by walking inside on the catwalk comfortably. And this is the lighting system. Now, to be able to produce fashion Mashrabiyya, let's say that, we need to have a proper equipment, the best equipment to handle aluminum sheet and have nice edge cutting. It's a water jet technology. And to be able to finish 80,000 square meter of Mashrabiyya in a 6 months' time, we cut the Mashrabiyya from a jumbo size sheet, 6 by 4, and that allows us to make double height Mashrabiyya, which is big one. Then we do the perforation, and then we send it for powder coating. The other element which I will talk about, which is the stone. The stone being used from more than 2,000 years in our area, and stone is reflect healthy, reflect holy building. It's been used in the mosque building and the churches in our area. Recently, some architects start to integrate the stone as a material in some of the towers in our city. And we will share with you one project we executed in Dubai, which is Conrad Hotel, where we used the granite 40 millimeter thickness, and we incorporated in the unitized system. This is in the Sheikh Zayed Road, it's congested area, similar to London, where you get difficulty in getting access and difficulty of moving around the building. So the tower is 255 meter height, and the granite is 30 millimeter. Some of the panels was 7 meter by 2.5 meter, and the weight used to reach sometime in 1 to 1.7 ton. There's some photos being taken from the factory where it shows the fixing of the granite on the panel. It was mechanical fix in addition to structure sealant to ensure that the panel is sealed 100%. And this is some photos showing the panels which been shipped to the site, and we left the panels by using a monorail to the right position. This is this photo been taken 3 months back. It shows the project after it's completed. Another element we'll talk about, which is the tent. Tent being used in the Arabic area for quite a long time. This is how the Bedouin used to build their houses when they traveled from place to place. And the advantage of this tent, it's made from a natural wool, where when it rains, it's expand and it's not allow water to go inside. When it's dry weather, it's give the air space to move inside, and it allow the air to flow inside the tent. One of the projects we executed recently, which is in KSA, was the architect also developed with us this feature, which been fixed outside on the wall. And here the element, it's quite big. It's double floor. It's reached to dimension-wise to 8.6 meter by 10 meter height. But in this project, we were forced to penetrate the system. It's different than what we did in ITCC. This is some photos being taken from the project during the erection. And again, the target was to provide shadow, to provide simple way of ventilation, flow the air behind the tent on the facade. This is some detailed photo being taken from the project. This photo we try to talk about the steel as a metal, the stainless steel, which again, it's recently some of our building, which is you start seeing a lot of stainless steel, especially on GCC. You will see a lot of stainless steel being incorporated on the curtain wall, and the impact is reflect economic aspects, which it shows reflect the building change the appearance of the building, and it's being used, for example, in Burj Khalifa. Burj Khalifa, we use almost 82 kilometers of stainless steel fence. We cover all the joint which come between the panels. We have a sample we presented in our stand where it shows you the fence being used. The total curtain wall area was 132,190 square meters of curtain wall. And the stainless steel was, this is showing the stainless steel fence which was used in the joint, and so shows also the system which got the flexibility to move with the building and expand also in the 4 directions. Now, we'll stop little on Burj Khalifa to tell you how we executed Burj Khalifa and our history with this landmark project. When we started delivering the first panel, it was in May 2007. We were almost 1 year behind the program. And you can see this photo, it shows clearly the situation. It was not good for us at all. We were almost, as I told you, 12 months behind the program, and when we started the installation, the task was how to go fast to cover all this massive structure which being casted. So the idea or the strategy we put at that time, we divided the project to 8 zones. And we put every zone, we tackle it as a different project. The target was to go fast, at the same time to maintain the quality and to keep the life of the people safe. So it's 2 difficult things to maintain at the same time. So we ask our team, we put project team for every zone, and we did a lot of planning to make sure that no 2 teams will work on top of each other. We study a lot the logistic ways, how to take the panel up and how to move the material in a safe way. Now, this is 10 May 2007. You can see the structure is already going up and there's no glass. And this was the first step we did. We give instruction to the first 3 zone manager to start in 3 different areas, 3 different elevations. And each one will move in the same direction, but we will never have a case where 2 teams will work on top of each other. So this facilitates the logistic a lot. Now, in September 2007, which is almost 4 months, we managed to install 5,125 panels. In November 2007, to 7,421. 2,000 panels installed in 2 months. It's almost like we start achieving 1,000 every month. And you can see the first zone being completed. Now we have to come down to close the electromechanical zone, the 2 floor. Usually in Burj Khalifa, every 40 floor, we used to have a double floor for MEB. And at that time, we used this double height floor for logistic. From that floors, we managed to take our panels out of the building for the installation. So to come back, if you see now, we sealed the area above that mechanical floors. It's not an easy task. You sealed the area above. So I designed an idea at that time by using trolley, which move on the terrace and provide access to the team to come down and seal that area below. This is the trolley which I designed at that time, which is simple, 4 wheels with a counterweight, but you can dismantle it to a simple structure profile, then you can take it up and assemble it. This shot being taken in level 148, where we use the same technique up. You can see the counterweight being put on the back of the trolley to balance the trolley, and the monorail, the hoist at the front, to be able to lift the panel from the floor below. Now, we use different technique. We design different methods for different area, different corners in the tower to be able to move fast. This photo in February 2008. Now, you can see the progress is moving well, and now we are almost 13,000 panel we managed to put on the structure. This is April, quite big change. 15,836. We are close, but now the logistics become more difficult. Closing these small pieces in the corners, every panel used to take 1 day or 1.5 days. Planning used to take sometimes 5 days, designing in new methods to take the panel up. And this is the challenge when you do high-rise building. It's the logistic, it is the safety of the people. That was our main concern. That's why you see me, I used to go with my team all the time to all this dangerous area to make sure what we design on the paper, it's applicable. Human, they can work in that environment safely, feel confidence. So here we were close, but still there is a top part which need to be glazed, which is very difficult. So we design a structure which can connect 3 floors together, 3 panels in each floor, and make 1 lift for 3 floors together in 1 shot. In August 2008, we reached to 18,985 panels. And here, the top part of the building, where we were 20,604 panels already installed. Less than 4,000 panels left to finish the job. Again, the photos reflect the critical area which is left, which is always NEP, corners, edge building, where, again, you need to design a new idea to be able to go and install these panels. This shows how Samsung, they left the spire up, and this shows the panel which I talked to you about it, where we connect 9 panels together, like we are lifting 3 floors 1 shot. And shifting this panel for 725 meters, it's not an easy task. We used to communicate with the civil aviation to know the wind speed, to choose the right time to do this kind of operation. This kind of lift used to take from us 25 to 30 minutes, and we used to have plan B in case suddenly wind came, that what will be done to take the panels close to the building or stop the operation, or what to do in case the wind came. The wind was the main challenge of our operation in this tall building. Now, in February 2009, we reached to 21, and you can notice now we are not moving fast. The first 2 or 3 slides We used to do 1,000 panel per month, 2,000 per month, but now it's 100, 200, 400 if we are lucky. In May 2009, we reached to 22,819. Then this photo, it's scary, where the people, they have to go and fix the stainless steel fence on the spire, and they are here working on a height of 828 meters. It's, again, the environment is safe. You look to the photo, you may scared, but the worker working in a very safe environment, the way they stand, the way, you know, the protection permit, they are working in a safe environment. This is a technique where, you know, we are now happy to put it for all the client, for all the contractors that they want challenge Burj Khalifa and make highest tower more, you know, they go more than 828 meters. Now, this is in October, where 2009, 24,384 panels was installed. And also you can see the BMU system with the heavy stainless steel pipe, 25 millimeter thickness, 30 centi diameter, being also installed. Almost the building very close to finish, the envelope. And this, as I showed in my previous slide when I talk about using stainless steel, the stainless steel being used here a lot in this building. And I think the appearance of the building, it looked beautiful, the way the architect he integrated to the facade. There's some photos being taken from different areas of the Burj, showing the MOU systems, showing the facade and the stainless steel on the terrace. There's some nice photo we took where we execute some project with an old Arabic, you know, design, where you see the arch on the building. You see, there's another nice photo I'd like to share with you. This is old shape of Arabic window used to be used in the old houses, where you have small windows pieces and you have some design on the bottom of the window. This photo reflects fashion, modern, and all the style of windows which used to be used in our area. Again, similar, some kind of mashrabiyya being used in the same area which surround Burj Khalifa. We did this project, this is called Old Town. Again, some other photos where we did the aluminium casting next to Burj Khalifa. And that's it. Thank you very much for your attendance.